Hello Year 11. As we approach the end of this GCSE course, and I know you'll all be glad to hear that, as indeed am I, we move on to look asynchronously at vectors. And all a vector is really is something that tells you how to move in multidimensional space. You'll be familiar with this from physics, for example, and also from the translations unit in this module. But I thought it would be useful for us to look at 3 questions that deal with the geometry of vectors a little bit more clearly. And the first question we're going to look at is this one here. We have 2 vectors, A is 4 and 1, B is 3 and 2. Now, before I go on with the question, it's just worth expounding briefly on what that represents. So, my generic vector, and let's call it V, and I'll underline it to show that, tells me how far I move in X and how far I move in Y, if I'm working in 2 dimensions, where my top number is how far I move in X, my bottom number is how far I move in Y. So this A means I go plus 4 in X and plus 1 in Y. And this B means I go plus 3 in X and plus 2 in Y. And you'll notice they both trace out a diagonal line of some gradient, and B's gradient is larger than A's. Now it's important to notice that just because these 2 are positive doesn't mean everything will be positive. And also to note that we could find the gradient of these. We know this is 4 and this is 1, so your change in Y over your change in X is 1/4. Equally, this is 3 and this is 2. Your change in Y over change in X is 2/3. So let's look at the question now. Write down as a column vector A plus B. So that's 4, 1 plus 3, 2. Now if we were adding those 2 vectors together, that's basically go along 4, up 1, along 3, up 2. Or in total, we're going along 4 plus 3, 7, and we're going up 1 plus 2, 3. And you'll notice that we didn't need to draw that out. We're just adding the x components and adding the y components together, because vectors describe movements in a certain direction. So I have 7, 3 as my column vector. Equally, 2a subtract b. I'm doing A twice. I'm going along 4, up 1, along 4, up 1. So that's just along 8, up 2. That's 2A. You'll notice I've just multiplied my components by 2. Subtract B. So if I'm subtracting B, rather than going along 3 and up 2, I'm going to go left. So along in the negative direction, 3 and down 2. Right, I'm subtracting 3, 2. So going along 8 and then back 3 in the other direction, 5, and then I'm going up 2 and then down 2 in the other direction, 0. And you'll note once again I've just done my components subtracting one another. So we don't need to think of these geometrically, but it's useful, at least for me in my own head, to think about exactly what these vectors represent and why I'm doing this arithmetic. Part B. From the point P, draw the vector C. C is 5, negative 4. And we have said that that means we go along 1, 2, 3, 4, 5. We go down 4. 1, 2, 3, 4. Because upwards and to the right are our positive directions. So that means my vector goes from P, it goes and joins to this point here, which is to the right by 5 and down by 4. And you'll note that my vector has a direction attached to it. My second question requires you to generate your own vectors. A is the point 5, negative 1, B is the point 4, negative 3. Write down the column vector AB. And so that's a vector going from A to B. So if we think about A, 5, negative 1, and then B, which is at 4 and negative 3, in space, I need my vector going from A towards B. So if I look at my x direction first, to get from A to B, going from 5 to 4, I'm subtracting 1 in my x direction. And if I look at A as at negative 1, I want to get down to negative 3, I subtract 2. So my vector AB is negative 1, negative 2. You will also notice I could have generated that by doing 4, subtract 5, negative 3, subtract negative 1. And that's equally valid, but I think it's good to draw this diagram. What do I need to do to get from x is 5 to x is 4? Subtract 1. From y is negative 1 to y is negative 3, subtract 2. C is the point 1, 6, D is the point negative 3, 9. Write down the column vector CD. Same idea here. I have C at some point which is 1, 6, and then D is at negative 3, 9. And I want my vector that goes from C to D. That's what that means there. Starting at C, going to D. So C starts at x is 1. We want to get to x is negative 3, so we're subtracting 4. C starts at y is 6. We want to get to y is 9, so I'm adding 3, giving me negative 4, 3. And once again, this process is just, what do I need to do to x to get from C to D? I need to subtract 4. What do I need to do to y? I need to add 3. And we have our column vectors. The third thing they can get you to do, and we're going to look at this a lot more for more complex problems in next week's final week of new content, is to deal with shapes that are described by certain vectors. So you'll see that this triangle OAB is described by a vector 5a and another vector 3b. Indeed, it tells you that OA is 5a and OB is 3b, if we needed to check. It also tells you M is the midpoint of AB, and I just label that on there. It means I won't forget when I'm working through my problems. We need to find, in terms of A and B, the vector AB. That's this vector here, from A to B. And the way I do this, the way I move around my shape, if I'm going from A towards B, is I look for a path I can approach using these vectors. So to get from A to B, I can go down this path and then along this path. Right, down this path, along this path. Now I notice that from A to O, I'm going in the opposite direction of my vector. And we said the opposite direction of a vector is the negative value. So to get from A to O, I've got negative 5a. If OA was 5a, in the opposite direction is negative 5a. Then I need to go from O to B. Well, I'm going in the same direction as my vector, so I'm adding 3b. So I've got negative 5a plus 3b. All I'm doing here is my start point is A. I'm looking for vectors I can travel along to get to B. This is my only path. I'm going against the direction of 5a, so negative 5a. I'm going in the same direction as 3b, so plus 3b, negative 5a plus 3b. The next question asks me for a vector AM in terms of A and B. And I note that AM, because M is my midpoint, AM is equal to 1/2 of AB. We see that here, right? AM is 1/2 of AB. They're both going in the same direction, but AM is half the length. And so, AM is going to be a half of negative 5a plus 3b, because that's what we had for AB before. In other words, it's going to be negative 5 over 2a plus 3 over 2b. And I have my result. C is even more complex. Find, in terms of A and B, the vector OM. So that's this vector here. I just do the same thing I did for AB. I look for what paths I could take. And these questions here seems like might have been a hint. Particularly here, AM, I'm going to look to use AM. So I start at O, I want to end at M, so I'm going to take this path, O to A, and then A to M. O to A, so I'll write that out actually. OM is OA plus AM, and OA is just 5A. And then AM we just worked out, plus negative 5 over 2A plus 3 over 2b. Or in other words, 5a, subtract 5 over 2a, which is 5 over 2a, plus 3 over 2b. And so I have 5 over 2a plus 3 over 2b. So the principle in this question that underpins what we're doing is if we're finding a vector, we start at the letter to the left, O, we finish at the letter on the right, M, and we look for a path of known vectors that we can take to get there, OA plus AM. And then we just use their representations that we've already found, either been given in the question or in a previous part of the question. As I say, you will get a lot more practice at that next week, but I think that skill set is very important, and you will be tested on some of the easier types of question looking at that approach in this week's Dr. Frost Maths. Hope you have a good week.